Dun, 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 dun. Hey, 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 it's me again. Oops, sorry. Again. How are we doing? Let's see what we are dealing with. Okay, let's start by recompiling all of our stuff. We send it, okay. Now let's start the camera. And we can see, can I, that seems too dark. Can I unlock this? There we go. Okay. Now we want to measure. Actually, let me pull that up on the big screen for myself. Now I can see what I'm doing. Oh, I can't see the value. Okay, this is ground. Oh my god, it works. I found the error. We found the error, guys. We found the error. The error was, funnily enough, we did the SPI setup down here right before we sent the actual values. So, as you can imagine, that, well, created, you know, a problem because the DAC didn't have enough time to, you know, to start up and actually recognize the SPI command. So what do we do now? Do we want to output a sine curve and see if that works? Let's try that. Let's create a, that's not what I wanted. I wanted a calc spreadsheet. So we will do 1, 2. Oh, hold on, no, actually we will do 0, 1, 2. And we will pull this down to 255. There we go. There we go. Then I will equals this. No, hold on, actually sine of we want 255 to map onto 2 pi, so this divided by 255, 256, right? And actually times 2 times pi. Okay, this should be 0, yes. Okay, we're getting funny values. Those are not... Hold on. That's actually not what I wanted. What do we want? We have the time. And we have 256 values on Y. So what we want to do is... Yeah, actually we are using the same values this time. So what we want to do is equals this. We want to do the same thing, but plus 1 and times 256 255. No, half of that. 128. Because that way we move it up. So 0 is at 1. No, hold on. I fucked it up again, didn't I? We need to do plus 1 times 128 and put all of this in brackets. Yes, now we're talking. Because we start in the middle, right? And equals is floor function. Looks like it. Okay. Now we have some integers. That's a lot of zeros. Well, who cares? I don't have anything bigger than 255, right? No. Oh, 256. That doesn't work. I have 256. Let's change that to, where is it? You are 255 actually. And now I need to get this into a C array. How am I going to do that? Let's see. Can I just copy it and paste it? I wonder what will happen. Yep, that's not it. Okay, now can I run a command on this? I don't think that's what I wanted to do, is it? Oh, it might actually be what I wanted to do. Oh fuck. Man, xxd array. Can put it into our dash I. And xxd dash I. This looks promising. Actually, no, it does not. We are increasing and... oh. We're converting the ASCII into what... yeah, actually, hold on. Let's just do this. We're gonna... record. And we're gonna stop recording. And we're gonna... okay. Can I paste this into... actually, let's close this part. Can I just... uint 8_t sign equals... fuck. I need to... damn it. Yeah, that doesn't do it. So I need to copy this in the other buffer. Okay. There we go. This might work. Okay. Then we will do what will we do? We will do while one actually we will do uint 8_t Is this the pointer size? I think so. Uint 8_t I equals 0, and we will do sign I if I bigger than 255. I equals 0. Yep, we got some errors. Let's see. What do you mean it's not used? It is obviously used. Is set but not used. Huh? Oh. There we go. Forgot to semicolon. Absolute classic. Now we will go back to our camera. Put it up. And oh, we are kind of overexposed, aren't we? Why can't I? Oh, I can unlock it. That is nice, isn't it? We are still heavily overexposed, holy shit. Okay, now let's see what we are getting out. I need to connect. Jesus Christ, are you hearing this? Is this annoying? I don't know. Yeah, I need to zoom the fuck out, holy shit. Isn't this beautiful? Pretty much 1 kilohertz, no. What are we doing? Spike to spike is like 2.5 milliseconds. So like quarter kilohertz maybe. No. Who knows what it is. But we have a sine curve. And it works. Isn't this amazing? Now we just need to... Oh! Do you think we can already measure the output? Did we set this up correctly for this? And where would the output be? Would be these two. Oh, that's not the correct output. Why not? Let's check our schematic. Switch to the desktop. Hold on, I need to read some messages. Right, we wanted to check out the schematic. So let's see. What do we have? This should immediately go in here and should work. And the mod 12 goes out. Oh, is it the other pins? Hold on. Oh yeah, I believe it is. Is it? Yeah, it is. Okay. Let me add our camera. So I think it is this. Now, what kind of voltage are we playing with? This is constantly at 12 volts. I don't think that's good. Why is it at 12 volts? Can we maybe not handle the frequency? LF351N. Oops. Let's check it out. Heyo, how's it going? LF351N. Have you already seen this? Look at this, it's amazing. I can... Oh, camera, where's the camera? We are generating a... Fuck. We are generating a... Come on, don't slip off again. Oh, I need to zoom in, don't I? A perfect sine wave. Isn't this amazing? A stable sine wave, who would have thought that? Now for some reason it's not getting... converted to our 12 volts. Can I, Jesus Christ, I just want the data, bruh, hello? I just want the data sheet, please stop popping up random shit. Okay. Let's see, this is, yes, don't care, maximum ratings, input, no. Ooh, do we have any timings here? Megahertz. That's probably not it. Because for some reason, when we take a look at our 12 volt output, which should be modulated from our sine wave, it is simply 12 volts constant, which, I mean, not what I wanted. So yeah, that's interesting. Let's see, maybe if we ignore the sine wave values. You know what, let's delete all of that. Kind of unnecessary. If we set DAC to 128, we should get something like 6 volts. Send, not set. My naming scheme is very inconsistent. Send. Hello? There we go. I didn't save it, did I? Compile, copy, and send. Now let's see. Are we getting the correct value? Nope, it's still 12 volts. That should not be the case. Huh. We're gonna have to do some electronics debugging, because this is not a software bug, this is a hardware bug. Oopsie. Okay, let's see. Okay, where were we? Where were we? That's an annoying phrase. No, don't. I want to go here. Right, how do we debug this? Yes, we're gonna have to use the camera for that one. Let me open the schematic on my screen. Oh. Okay, let's check all of our connections. So I mean if 5 volts is 5 volts, wouldn't it? Let's check how if there's a connection between the 12 and the modified 12 volts. Because there should not be. Oops, what the fuck? Please stop it. Okay, how do I reach underneath there now? That's gonna be... Let me put up the camera on my big screen. Okay, I got it. I'm running out of desktops. Okay. Need the 2 middle pins on this side without touching any of the other ones. Yeah, I think I need to pull this off, unfortunately. It's gonna be annoying to put back on later. Okay, let's hope there's no sound. Oh. What does 811 mean? Is that resistance or something? Let's see. We are getting 96 kilo ohms of resistance between these two. Let's check our sheet. There has to be... Oh boy, I'm feeling the insulin spike. Is there any like resistance? Input resistance. 10 to the power of 12? That's something different. What's our schematic saying? 12 and mod 12 should not have a connection unless between internal stuff. So then we have 680 to this pin, which means mod 12 to this pin. Okay, back to the camera. Bro, my model isn't tracking. God damn it. Why is no one telling me these things? There we go. And let's see. We want, I think, It was this pin to this. Oops. Oh, come on, bro. Ah, these pins are... I'm on the wrong screen. Hold on, which pins was it? Yeah. I was right the first time. Who would have thought? Okay. This, oops. This pin to this pin. Hello? How many? Did I fuck up this resistor? What kind of resistance is this? Hello? 2K, let's see. Bro, can you connect? What is going on? Okay, no, 7G. Okay, so that would mean this pin to this pin. Wait, why is this 1.2K? These two pins, does that make sense? Let me check. What? Something's wrong. Wait, what? Is there any connection between these two pins? Like, this needs to be connected to this. It is. And this to this. Don't think it is. Why no? Hello? Let me check the schematic again. Oopsie. No, these two should be connected. Okay, we need to disassemble the thing again. Okay, let's see. Where's my connection fucking up, huh? What's going on here, huh? Hold on. I need to think. Okay, we have... I think this is 12... no. Huh? Is this 12 volts? It could be. Looks a little bit like it would be 12 volts. This should be 12 volts. The one below that is our mod 12, which has the connection. Oops. to our resistor, right? Come on, touch it. Why aren't you touching it? That is a connection, okay. So, now for some reason, let me zoom out. I am on the wrong screen again, hold on. Okay, there we go. Well, okay, let's set this to 2K. And I need to connect these two pads. Oh god. Okay, 1.7K. Wait, what? What do you mean 1.7K? It's supposed to be 680. Huh? Am I touching the wrong things? This and this and... No, this is 660. So what is going on here? Probably touching the wrong ends, aren't I? Wait, how many things do we skip with this? We skip 2 holes. Okay. So we need to measure underneath that cable, bruh. Okay, yes, this is connected. Now, this needs... This isn't connected to anything, is it? What is it supposed to be connected to then? Supposed to be connected to the other resistor, but this is that one. The fuck is this pin? On the other side, nothing. Nothing. What is it on this side? Connected to this pin, which is... Oh, I think we fucked up our connections over here, huh? Let me turn on my iron and let's correct that. To connect these two pads. Oh, don't. I am in so many layers of cables. I need to be careful to not accidentally tug on the cable that is attached to the hot iron and launch it into my room. That would be less than ideal. Oh, also I've been thinking about segments I can do on stream. If you guys have any funny ideas or have any videos I should watch or something, you know, just type it in chat. Why is this? Okay, I need to go like I don't like that. Let's see if we can do this. Meme review. Damn, you have some memes? Oh, the Discord channel has some memes. Don't we? Where's my tin? There we go. Camera, please. Okay, I need to connect these two things. Damn, that was easy. Come on, clean a tip. Always clean a tip, chat. Add some protection to the tip. You can go through my meme folder. I have like, what, 3,000 images in there. In like the most recent folder. You need to what? Find new ones. I don't know what kind of commentary I'm supposed to give on memes. Can you like give any commentary on that? Okay, let's zoom out and fix this. Back in there. Okay, let's see. How are we doing on this? Lines up? No. Does it line up? I don't think it lines up yet. Rate them. Also, I need to watch out to not... Like, there are memes that will get me cancelled. Okay. Wait, is that in? Hold on. I think we're in on this side. Let's check this side. I think we're also in. And this is also in. Press everything down. Come on, okay. And fuck, which one was out? This one was out. Hold on, I need to see if I'm actually plugging this thing in or if I'm... Oh boy. Oh, what's smelling so bad? Did I touch the box or something when soldering? Okay, let's see. Plug it in. Is it? Oh, it's not in. Yeah, let's correct that. Oh shit. Did I create a short? Where's my thing? I knew this resistor was not in the ideal position. Oh god. I think I got it. No, I don't. I don't got it. What are we connecting? Okay, let me plug it in again. Damn it. Oh god, somewhere there's a short somewhere and I don't know where. This thing, oh boy. Oh boy. Oh, that's not good. Look at this black cable. Ooh, where's my tweezer? Look at this. It fell off. I don't even know where it's connected to. Yep, that's an oopsie. So we're gonna turn this back on. Gonna somehow try to isolate, get off the... Ooh, how do I get my arm there? Get some of that isolation off. Let's see. There we go. And now we want to... Oh boy. Let's try to not melt everything. Okay. That part out. Now we want to bend this up a little bit. Ooh, bend this that way. Bend this like this. Shit. I need to find the hole. Oh boy. Okay. Now I have successfully connected the ground with the 5 volts, which is very bad. Where do I have my copper? There we go. Oh shit, don't touch the plastic. I'm gonna use my sucker. Slurp, slurp, motherfucker. Jesus Christ. Okay. I think I got it. Let's plug it in and hope we're not blowing the fuse again. Okay. Looking good. Looking good. I can turn off my iron. Okay, okay. Now let's see if we are almost done with the project. I think there's not a lot of steps remaining. We just need to add the foot pedal. If this works. Now, if this works. Probably not. Don't count your... What do you call? Don't count your sheep before... No, don't count your chickens before they hatch. That's how you say that. Okay, let's see. What kind of voltage are we working with, huh? Should be around 6. So 4, I guess. Interesting. Okay, what happens if we... Let me really quickly... Oh, I actually need to... let's set this to the maximum value. And I need to reset that. Copy and send. Let's go back to the camera. Now we should be closer to the 12 volts. 8.5. Well, that is not what I expected at all, but at least it's higher than 5, you know? Oh boy. We might need to change the resistors if we don't actually get enough voltage. And actually, wait, hold on, what are we getting out of our DAC? Should be something like 4 point, maybe 3.9, 4.1 volts. Let's see. You touch that part. You touch. Oh Jesus Christ. How do I don't want to focus on my hands. This is so annoying. Okay. Yeah, 4 volts. Yeah. I don't think we can get this any higher, but we can hello, there we go. Change our voltage divider here. That yeah, that we calculate this with 4 volts instead of 5. What would we... I can't do math. Actually, hold on. Yes, I can. This needs to be twice as big as this resistor. So, I don't know, 470 and 1 kilo ohm. That should work. So we just need to change this one. Yeah, this resistor is wrong. But I mean, who cares? So now what do we need to do? We need to do this. Okay, so we need to do, I think we want a PID regulator. So PID regulator. Okay. So that way, okay, we're gonna do some math now. How does this work? Very simple. We put in however much current we want, right? Then this value gets put through some functions with some parameters. We have to just, now you can't try to calculate them, but they're usually wrong, and we just experiment to find something that works. All of that gets summed up, and out comes our voltage. Voltage. Now our out comes our voltage, right? Then we have our process, which is in our case the needle in our skin, converting, like having some resistance, which means that at the end we get some current. This current we put in here, and this, since this is negative and this is the current we want, this is the current we have, we always regulate to get this to 0. That way every step we get a new measurement which updates our output, and we go round and round. Now, how do we actually measure our current? That we do with there's my schematic. This resistor, 10 kilo ohms. So we will simply measure the voltage on this pin against ground, and since we now know the voltage from here to here, we can, hold on, it's voltage equals resistance times current, so voltage divided by our known resistance of 10k gets us our current. So let's first measure our current. For that we need, where is this one? Let's open this one too. And what do we want? You hate math. That's unlucky. Yeah, me too, actually. It's sometimes necessary, but the math is not really the fun part. Okay, now what do we need? We need the ADC, analog to digital converter. How do we measure this? Starting a conversion. Pre-scaling, interesting. What? When we have a clock to pre-scale. ADC diagram. What? ADC clock? We convert. Oh, we have. Oh boy. Okay. 25 cycles for one conversion. Oh, this is way more complicated than I thought it would be. Voltage reference for the ADC. Vref indicates the conversion range for the ADC. So be selected as either AVC. Oh, this is a 12-bit converter, interesting. Channel 1.1 reference. Can I not do this against ground? Hold on. Arduino pin out. There is like a VREF somewhere. Oh, AREF, probably this one, right? Okay, we don't use that pin. We have all of the analog stuff here. Analog input circuitry. Cool story, bro. Bunch of stuff. ADC conversion results. After the conversion is complete and the flag is high, the conversion result can be found in the ADC result register. For a single-ended conversion, the result is Vin times 1024, the voltage on the selected input pin, and Vref is the selected voltage reference. Interesting. We don't need to calibrate this, do we? Calibration values determined during tests are available in the signature row. Oh, you can measure the temperature with this, that's funny. Multiplexer selection register. Reference selection bits. AREF. We don't use that pin. Oh, hold on. How do we test this? Oh, I know how. AVCC internal capacitor at AREF pin. What does that mean? Reserved based 1.1 voltage reference. I think we want AVCC, whatever that is. Let's see, noise canceller, conversion result. There has to be some explanation to AVCC. ADC, a separate analog supply voltage pin, AVCC. Oh. How are we using that? Which pin is that? Let's see, not this one, this chapter. Okay, do we see any AVCC in here? Oh, we do. That's actually just a pin. Huh. Arduino Uno schematic. Let's see, where is that connected? I think this is the one I know. Oh, god damn it, I just want the image. Open image in new tab. Okay, AVCC. It's just connected to 5 volts. Based. Okay, so we can use 5 volts as our thing. So let's make a new function called ADC setup. Void ADC setup. Hello, void. Okay, first register AD max. AD max equals. So we want these two to be 1. So 0, 1, what is ADLAR? ADC left adjust result. The LD ADLAR bit affects the presentation of the ADC conversion result in the ADC data register. Write 1 to the ADR to left adjust the result. Otherwise the result is right adjusted. What the fuck does that mean? Oh. That makes sense, yes. I think I wanted 0. Yes, left adjusted, that makes sense. So 0, so 1, 0, that's a 1, 2, 4. 0x4, okay. Max. Analog channel selection bits. The value of these bits select which analog inputs are connected to the ADC. See this table for details. What the fuck? Why can I set them to ground? Oh, no, actually that makes sense. If your AREF is the value you're measuring, wait, why didn't I do that this way? No, I'm using A0. So, wait, which one is A0? A0, this one. So, this one, ADC 0, I assume that's the one, right? Didn't actually check to know which one was which, probably in pin configurations, right? ADC, Control F, ADC 0. PC0, yes, ADC0, that's the one we want. So that's all 0 based. Let me drink something. Okay, next register. ADC SRA, ADC control and status register. Enable. This, we might want to set this last. We will see. AD enable. Okay, ADSC. In single conversion mode, write this bit to 1 to start each conversation. in free running mode, write this bit to 1 to start the first conversion. First conversion. The first conversion after ADSC has been written, after the ADC has been enabled, or if ADSC is written at excuse me, the same time as the ADC is enabled, will take 25 ADC clock cycles instead of the normal 13. This first conversion performs initialization of the ADC. Will read as 1 as long as the conversion is in progress. When it's complete, it returns to 0. Okay, so we want to set this last. So we have 1 auto trigger enable. When this bit is written to 1, auto triggering of the ADC is enabled. The ADC will start a conversion on a positive edge of the selected trigger signal. The trigger source is selected by setting the ADC trigger select bits. Is that just for external stuff, or is that also clock stuff? Oh boy, I'm feeling the insulin spike hit, bruh. Let's see, the next one is the interrupt flag. This bit is set when an ADC conversion completes and the data registers are updated. ADC conversion complete interrupt is excluded if ADIE bit. Wait, what? Interrupt is executed if the... oh. Do we want an interrupt for this? I don't see why not. This could be our timer for, you know, like instead of using another timer for this PID system, we can simply use this interrupt, which is probably timed. So we just write this to 0. So 1 auto trigger, I need to figure out what that is. One something 0. Let's see, what is this? Trigger select bits. ADCSRB. ADCSRB, control and status B. ACME 0. Wait, why is ACME not described? Oh. Actually, I can run this off the same compare match A. I can run this off the same interrupt as I'm running my other timer. Don't know if that's smart. Or if we want second timer for this. Actually, let's just run everything on like a 1 kHz cycle. That should be fine. So not overflow, but compare match A, I think. Right? Where's my vector? Compare match A, timer 0, compare A. So Let's set that to 3. ACME. What is ACME? Data input disable register. What? Digital input disable register. The digital input buffer for the corresponding ADC pin is disabled. Oh. Let's see, what is ACME 0? ACME. Analog multiplexed input. What? Replace the negative input to the ADC multiplexers used to select this input. Analog comparator multiplexer. I don't think I need this, do I? No, I don't. Just set that to 0. So we have what registers? There we go. 0, 3. I forgot the name. This equals 0x03. And now the control register A. Which did we, well, what did we say? Auto trigger enable, yes. 1, 1, 1. Interrupt flag 0. So E. Oh, copy this. Equals 0x E. And the other one was interrupt enable. Kinda want to do that, yes. Prescaler 0. The fuck is the prescaler? Between clock, system clock and the input clock of the ADC. Why can I set this to 0 or 1 and it's both 2? That's funny. So let's set this to 8, 1, 9. Okay. Now I need where are my interrupts. God damn it, what's ADC? That's probably it, right? So I'm gonna ADC. Where are my globals? Can I want to set the ADC value over here? U and 16 because we have 12-bit. That's a lot of resolution actually. UL. What do we call this? Shunt. Okay, let's see. What are we doing here? ADC. And what is the register looking like? I'm scrolling in the wrong direction. We have this. Okay. Fuck. Oh. ADCL. So. Oh my god, how do I set this for? I think I need to barrel shift this. Okay. What did I call it? Shunt equals ADCH, right? And then shunt equals shunt left shift 8, right? I think so. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, yes. And then shunt or equals honestly plus is the same thing. Plus ADCL. Ooh, okay. And this should read some funny values. Can I? Should I set an old shunt so I know when it changed? Probably, right? U int 16 underscore T old shunt equals 0. Old shunt equals shunt. Okay. If old, wait, no, you don't set this. I set this. Old shunt not equal to shunt. Old shunt equal shunt. And what do we do? We have 16 bits. Can we do some funny calculation? You can probably set the current or something to okay, first we need to calculate the voltage. How do we do that? Kinda do need floating points here, don't we? Or can we... I can do that with integers actually. So our 5 volts equals 12 bits of 1. Now we want the ratio of that. we have the ratio. How do we convert that ratio as integers? Oh, I know. Hold on, how many spaces do I have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. Yes. Okay, so what we want to do is uint $16t array voltage equals shunt times 0x 3ff divided by, no, wait, yes, hold on, I need to think. This divided by 50,000. Okay. Actually, hold on. 3 in decimals. What would that be? 1023. Yeah, actually we don't have that much. So times 5 volts. It's almost the same thing, right? I'm just gonna do times 5. And then we will set current voltage. Did I save? Goodbye. Oh, first try, baby. Okay, we are getting a lot of zeros. Oh, nothing is happening. Let's switch to the camera. Oh, you know what happens? We are not actually ADC set up. Not actually setting it up. I just realized something. We are taking longer to write it than we are taking to measure it. That's not great. Let's set the prescaler to something insane, like 128, so 3, 4. Where is the A? Yes. Fast prescaler, and you will, instead of 9, you will be 8 plus 7. Right, this will be an F. Okay. 400. Why this priest gator is fucking stupid. It's the clock that's the problem. What am I doing? Okay, now just let's see what we get. 5115. Okay, now if I fuck if I touch this, I should get different values, but I'm not. Okay. Yeah, this writing takes too long. Something is wrong here. But I'm pretty sure we are measuring something. Although we are measuring 5 volts. Which is weird. We should not be measuring that. I think that is a problem for tomorrow, actually. So... bye-bye. Who will I send you over to? Press the rate button and see who comes up. Kitties, please. Geology. Huh. I don't see anything regarding electronics, so I guess we're just gonna end. Goodbye, take care, sleep tight.